So after marking the value of 0.358 lambda, we will stretch a line which passes point from the center of the Smith chart to 0.358 lambda, and wherever it cuts or intersects with the VSWR circle, that is the value of YD1. So to read the value of YD1 over here, okay, the value of YD1 will be the circle, the resistance circle which passes through this intersection and the reactance circle. If we clearly see it, okay, then the reactance circle, the resistance circle which passes through this point is 0.55, whereas the reactance circle is 1.08. So YD1 value is 0.55 minus J 1.08 because it is coming in the second half of the Smith chart. So here we have marked the value of YD1. So YD1 is 0.55 minus J 1.08, which is 0.55 here and 0.8 here, which is clearly marked on this Smith chart. Now let us go to the next step, which is a step number 7. Here I wanted to find the value of Y11. Now we know that Y11 will be on the spacing circle. Why? Because Y22 has to be on the unit circle. The real part of Y22 should be on the unit conductance circle, which demands that the real part of Y11 should also be on the unit circle. So what I will do is, from YD1, we will walk on, or we will move on the unit resistance circle, okay, and wherever that unit resistance circle touches or reaches or intersects with the spacing circle, that point is my Y11. So from YD1, I have freedom of moving in two directions. One, either I can move upwards like this, or I can move downwards like this. So there will be two values of Y11. One I name it as Y11 and the second I name it as Y11 dash. So here are the two values of Y11 and Y11 dash. So because I am moving on the same conductance circle, the real part value will be the same as that of YD1, which is 0.55. But the reactive value will change. Here, the intersection reactive value is J 0.11, whereas here at Y11 dash, the reactive value is 1.88. Just wherever they intersect, read the values that are Y11 and Y11 dash. So now I am going to get two solutions, one for Y11 and second for Y11 dash. Now in step 8, we will find the value of YS1. Okay, we know that from the previous analysis, we have seen that Y11 is parallel combination of YD1 and YS1. So I will add them both. Okay, I know what is Y11, I know what is YD1, but I don't know what is YS1. So from this equation, we can write YS1 to be equal to YD1 minus Y11. Therefore, YS1 becomes J 0.87. If I consider Y11, this is YS1. If I consider Y11 dash, then I will get YS1 dash. There will be two peculiar solutions for that also. And that will be minus J 0.808. So I have received my YS1 and YD1. So YS1 now is 0.97, which is here I have plotted. Okay, so from the center, the value of J 0.97, which is on the reactance circle over here, and I have plotted a straight line which is passing through 0.97 J, and it intersects the wavelength towards the generator, and the value of wavelength towards the generator comes to be 0.1123 lambda. We also had YS1 dash, which was 0.080, which we can also plot separately, and we can have its lambda also. So you can give two solutions. One solution with J 0.97, the second solution will be with respect to J 0.08. I will concentrate on 0.97J only. Here, YS1 is the reactance. No, I can't say reactance. We have to say admittance because now we are dealing in Y parameters. So the admittance provided by of YS1 is provided by the stub. Now, what type of stub I'm considering? I'm considering the stub to be a shunt stub which is short circuited. Where is my short circuit point? In the Y chart, this is my short circuit point, whereas this is my open circuit point. So from short circuit point, okay, I will travel on wavelength towards the generator and reach up to 0.97J. That will give me the value as 0.25 plus 0.123 lambda, which is nothing but 0.373 lambda. So the length of the first stub, that is L1, is 0.373 lambda. So we have reached up to the first stub, and we have gained the first length or first stub length, which is 0.373 lambda. Next, in the 10th step, I will find the value of YD2 because we are now proceeding towards Y22. So to find YD2, okay, what I will do is, we know that the distance between YD2 and Y11, the distance between YD2 and Y11 is 3/8 lambda, correct? So I need to move 3/8 lambda from Y11 to reach up to YD2. How will I do that? We know that, let us consider this to be my Y11, right? Which is on the spacing circle. If I move 3/8 lambda, where will I reach? I will reach on the actual unit conductance circle, isn't it? Because the distance between spacing circle and the unit conductance circle is also 3/8 lambda, isn't it? So when I move from Y11 on VSWR circle, okay, which I will make, okay, so I will reach where? On the unit conductance circle. That means I will reach exactly at unit conductance. How will I do that? Okay, take a radius from center to Y11 and draw a circle. Okay, now you cannot take the intersection at this point because this will never be 3 lambda by 8. You can see if I rotate this whole circle, okay, when I rotate it this side 90 degree, this portion, the lower portion of the unit conductance circle, will be on this side, correct? Then I will touch this side. When I will rotate it, it will come above, and when I bring it down, it will be on this side. So down portion is reflecting over here when I'm rotating it by 3/8. So this portion Y11, okay, we will draw a VSWR and we will find that wherever it intersects 3 lambda by 8 distances, that is the point where YD2 exists. Read the value of YD2. Okay, real part will be surely 1 because it is on the unit conductance circle, and the imaginary part we have to take care. So it is 1 minus J 0.61, that is YD2. Same thing you can do with Y11 dash. Okay, so when I do Y11 dash, I will take from center up to Y11 dash, make a VSWR circle. Now it has to intersect the above portion because this side of the spacing circle represents this edge of the unit circle, the above edge of the unit circle. Okay, so I will reach up to this point and it will be YD2 dash. Now we know YD2 dash and we have to find Y22 and YS2. So let us go to the next step. Now let us find the final step. Okay, before going to final, I just wanted to add one thing over here. We see that we have already reached the unit circle. Now the only extra part that we have to remove is this reactance. For YD2 solution, 0.61J is extra, which is minus, so I have to add plus reactance and it will come at the center. For YD2, 2.60 plus 2.60J is extra, so I will add minus 2.60 and it will come to the center. So I have to add a stub which will provide a reactance of plus 0.61 and I have to add a stub to which will provide a reactance of minus 2.60 so that I can reach to the center of the Smith chart, right? So that will give me the YS2 part. So for YS2 part, I have to add a 0.6161 reactance. So I will first find where is plus 0.61 J, we will find that. So which comes over here. Okay, this is 0.61. Stretch a line connecting the center of the Smith chart, passing through 0.61 and extend outside till it cuts the wavelength towards the generator scale, and see what value it gives. So it gives a value of 0.087 lambda on wavelength towards the generator scale. Now, because it is short circuit, from this point onwards, it will be 0.25 plus 0.087. So that will give me 0.337 lambda. That is the length of the second stub. Now, we have considered only YS2 as the second stub solution. There will be one more solution for the second stub, when we will consider YS2 dash, right? So the complete solution will be, we had ZL and voltage source, then we have a transmission line, we have first stub, second stub. The D1 distance was 0.40 lambda from the load, and L1 that we have designed is 0.373 lambda. The distance between the two stubs is 3/8 lambda, and the length that we have achieved for the second stub is 0.337 lambda, and we have achieved Y0. Thank you.